Hi everyone, the purpose of this video is just to introduce you to the LTSpice software, which we're going to be using for simulating circuits and designing circuits. This software is freely available from Analog Devices, who are a major manufacturer of integrated circuits and all kinds of electronic components. Spice itself is free and open source software. LTSpice is the sort of front end and packaging of that, which has been produced by Analog Devices. It's free to use. Spice is probably the most widely used software for simulating circuits. And then within that, LTSpice is probably one of the most popular specific tools. So we're going to be learning how to use it. You can download it from this website. I will give a link to this as well. You want to download the latest version, which is up here. It's super recent, January 16th. So you can download the Windows or the Mac one, whichever is appropriate for you. You'll also find in here some instructional videos and tutorials, which you can look at if you want to go beyond what I'm going to introduce right here. Once you've downloaded and installed it, you can start the software up. And this is what it looks like when it starts up, which is a bit weird, to be honest. It's got this big picture that looks like a coffee stain, and it's got a little bit of an old-fashioned interface to it. It's a bit 1990s, and it's free. So what you gonna argue with? So anyway, I will take you through in this video just some basic setup and go through some exercises, learning how to actually use the software for some interesting things and for some interesting calculations. Okay, so you've got a toolbar at the top. The first icon on that toolbar is this one, which has a little play button on it. This is the Start New schematic. You can also start that from the file menu right here, new schematic, or Control N. So we'll run that. You get a blank sheet, little X crossbar. Now I have modified my sort of basic setup of this a little bit from the default. So you might find your background color is a little bit different. Your crosshairs are a little bit different. All that is editable here in the control panel, the little hammer icon. If you go to drafting options, there's various things you can change here, like the color scheme. I kind of changed the color scheme a little bit from the default. Yeah, some other things like the font and the rest of that stuff. I did also, so all this you can change if you want, or you don't have to change. It's just mostly visual. There's one thing that I would change, which is a default. The second item here, automatically scroll the view. This defaults to on when you first install. I would strongly advise turning that off. It's really annoying feature when you move to the edge of the screen. It makes your schematic that you've drawn scroll. I don't know, maybe it's useful when you're working with really huge schematics, but I just find it really annoying. So I turn that one off straight away. The rest of this we don't really have to look at the moment. Okay, but that's the control panel here. The next thing is the little running man, which is for simulations, and the hand also for simulations. We'll come to those in a bit. We can zoom in and out. There's some stuff about waveforms, arranging your windows, standard sort of cut, copy, paste, and print. And then the most important area is this area to the right, which is all the stuff for actually drawing and preparing your schematic. So I want to go straight in and start by just creating a really simple circuit. So I'm just going to do a resistor and a power source. So up at the top here, you have resistors, capacitors, inductors. The resistor is right here. I'm going to take a resistor. I'm going to stick it on my screen. That's a single click. Once you're in the sort of resistor placing mode, you can see my cursor is turned into a resistor. Anywhere you click, you're going to drop a resistor. We only want one for this, so press escape to go back to sort of the crosshair mode. Once you have a resistor placed, there's a couple of things you can do. You can move the window around a little bit. This isn't moving the resistor, it's actually moving the whole window. That's just by dragging on any bit of white space. You can also zoom in and out a bit. I don't like the zoom it starts with, I always go out one. So you'll see the resistor has a name. Its name is R1. And it also has a value which is just defaults to R to begin with. So the first thing we're going to do is give our resistor a value. So move to get the little finger, right click, and you can type in here the size of the resistor that you want. So we can do 120, for instance. It knows about standard SI symbols. So for instance, we can do 120K, it knows that's 120,000. G is giga ohms. Mega ohm you can't do with an M. It's one of the biggest sort of initial trip ups you can get with this software. If you want to do M means milli. If you want to do mega, you have to do meg. Okay, but we're going to keep this one at 120. You can also put in a tolerance and a power rating, but I'm going to skip that for the moment. Okay, and you'll see it actually shows straight away the value on there. You can change the name if you want. You can right click onto it and call it, resistor, whatever. Usually for the resistors, just the automatic name is fine, but maybe you want to give some component a special name. Next, we want to include our voltage source. I'm going to put that over here. The different options up here include resistors, capacitors, inductors, diodes get their own little slot. Everything else is just component. So if you click on component, F2 works as well. You get this component selection. There's a whole bunch of different components here, which are just given kind of difficult to read sort of file names. There are then even directory folders here with even more things. So later on, we're going to be looking at op amps. These are all the different op amps that are available here. Lots and lots of them. But we want a voltage source. It's in this first directory. And you can, if you want, just type volt like that, and it will come up with this one. Voltage is just a generic voltage source. Click it. Press OK, and you have the component to place. Again, as you move around, when you click, it drops one. It's ready to drop another one as soon as you click again. So be careful about double clicking on top. Sometimes you can drop two components on top of each other. Okay, once you have the component you want, again, press escape to go back to this view. So I want my voltage source to have a value. Again, I can right click on it. You get this basic window. You can put in a voltage value. Let's make it 5 volts, say. Series resistance. I'll come to series resistance and voltage sources another time. At the moment, this is all we need, but just to quickly show you the advanced tab, the voltage source, as well as just being a DC source, you can make it be like a pulse or a sine wave, various other kind of shapes of voltage source rather than just a constant voltage. For this one, we just want a constant voltage of 5. Okay, and again, if we want, we can rename it. We'll call it source, but you don't have to. Okay, once we have these two components, we want to connect them together. We draw wires with the little pencil. You get this big crosshairs now when you're in wire drawing mode. go to one of the terminals of one of the components, click and let go. It'll draw a line out. Click again, and it'll draw another line. Click again, it'll draw another line. You'll notice it's clicking by grid, and it will only go up, down, or left or right. There's no diagonal lines allowed. And then you bring it down to a terminal of another component, in this case a resistor. Click, and we've now connected our source to our resistor. Now we can connect in the other direction as well to complete our circuit. Okay, so there we have a simple little circuit drawn. Now you can just use LTSpice for drawing circuits like this. It can be useful for if you draw a circuit for a report or something. You can use this as just a drawing tool. However, the main power of LTSpice is to be able to actually simulate what would happen if you set up this particular circuit. It knows all about electronics, and it's able to do all the calculations to work out currents and how the currents will change with time, etc., etc. So we're going to simulate this circuit and try and work out, for instance, what is the current through our resistor here. You could just use Ohm's law to work that out if you want. You can do that on your calculator right now to check what you should get if you like. Voltage source of 5 volts, resistor of 120 ohms. Straightforward. One little thing we do need to do before we run any simulation is we have to define a ground zero voltage point on the circuit somewhere. Now you can build a circuit like this with just a battery and a 120 ohm resistor, and there is no ground as such. It's not connected to any other circuits. It's completely floating, and that's fine. But for the purpose of the simulation, we need to define where zero is, and so to do that, we click the ground symbol, which is here next to the pen. Move down. You can put it pretty much anywhere you like. I'm going to connect it here. I dropped the symbol, I press escape, and this is just like a component like the resistor, but with just a single connection. And I'm going to draw a wire from there to my circuit. So now this makes this point connected to ground, which of course means all of this wire from here to here is all ground level. In other words, 0 volts, and all voltages will be measured relative to that point. We could have connected it at the top. If we wanted, we could connect it to the other part, in which case this would have been minus 5 volts on this side and 0 on the top. As it is, we're going to have plus 5 volts on the top and 0 at the bottom. It doesn't make any difference to the actual math at all and to the outcome of the circuit, but just the internal math of the simulation software requires there to be a ground. Okay, so once we're happy with that, I'm going to escape out of drawing mode, and we're going to do a simulation. We're going to calculate this. So a couple of different ways to do a simulation. I'm going to start with the most straightforward one is to just click the little running man here, and it's going to straight away give you this simulation command box. And the reason I want to start it like this is that we have we can see all the different kinds of simulations we can run. So we can run transients, which means we model how the circuit will behave at the moment we turn it on from t equals 0. That's very important for circuits that involve components which are time dependent, like capacitors. We can do AC analysis, so we can see how circuits are going to behave with alternating currents. We can do a DC sweep, where we can recalculate the circuit at a variety of different voltage levels to see the overall effect. We can do noise analysis, so we can kind of simulate what kind of electrical noise we might pick up with this circuit and how that will affect our readings. DC transfer will come to another time, and we can also do transient frequency response, where we can see what happens when there's a frequency change within the circuit. The one we're going to start with is the simplest, DC operating point, which literally does what you've been doing with your equations so far with your Kirchhoff's laws, etc. It just works out what will be the equilibrium currents and voltages throughout the circuit. You'll see there's basically no options on this one. I do want to point out at the bottom here, there is this dot op. I'll come back to what that means in a moment. Let's click OK. It actually runs the simulation right away and pops up this little window. It's slightly annoying that you can't do anything until you've got rid of that window, but that's the way it is. You could copy and paste this into another notebook or something if you want. So this is the output of the simulation. You'll see we have a voltage, two currents. You'll see the names that I gave to my two components, resistor and source, appeared here. This is where it's useful to name things. And it tells us the current through this resistor is 0.041667 amps. The current out then of our source is negative of that. And then you'll see as well that we have this voltage of 5 volts. It says volt N001. So N001 is what's called the net ID. I will come to that now. So as you look around the circuit after you've cleared it, if you look down in the bottom left-hand corner of the window, it says this is node N001, DC operating point, B N001 equals 5 volts. So I didn't actually, excuse me, I'm going to this DC operating, so this is what we call the node or the net. So every point in the circuit where you have like a wire like this that's connected from here to here, that's complete conducting path, that's all going to be one voltage in a simple DC circuit like this. And so this is what we describe as one particular node, and that's the identity of it. This N001 is the name that has been given basically to that piece of wire. And each piece of wire that has its own unique voltage has its own unique name as well. At the bottom here, you'll see this one is ground, because all of these wires are connected to the ground connection. This here will be ground. All this will be 0 volts. Now it does just create the names of these nets itself. It's called this one N001. You can give them names yourself, which can be useful for more complicated circuits. So for instance, this is our power line, our power voltage from for the circuit. And so a common name for that is VCC. I could choose to label that. Oops, I'm going to put in here VCC. And port type none, and just click this, and now I'm going to click somewhere on this wire. If I run the simulation now, you see it's called this VCC. So it says VCC is 5 volts. So this can be useful to label these voltage. We'll look at more complicated circuits in a minute where there's several nets that might all have different names. And so it's useful to know what the voltage is where. So this is going to be 5 volts right here. Okay, let's make this circuit a little bit more interesting. Let's put a couple more resistors onto it. So I'm going to grab a resistor. I'm going to put one here. I'm going to keep the name it gave it, R1. I want to put another one, but I want to position it horizontally here. So whilst I still have the resistor enabled, I will go up to the toolbar and click the rotate button here, which will rotate the thing in the direction I want. Okay, you can also press Control and R anywhere you want, and that rotates it to the way you want it. So I'm going to put it here. Escape to get rid of the resistor, and then I'm going to hook these up. This one to here. This one to here. Escape. And I'm going to give my resistor some values. I'm going to make this one 120 like the other. And I'm going to make this one 220. Okay. And now I will run my simulation again. So now I've got a few more things. I've got now 4 different currents, the 3 currents through my resistors and the current from the source. Don't for the moment pay too much mind to the fact this one is R2 is negative and R1 is positive. Just as when you're doing the Kirchhoff laws, it's not it's not so urgent to work out exactly what sign it is. It's the magnitude of the current that's important to us here. So that this current, like to look at it, looks like R2 and R1 are going in opposite directions, but of course the current is continuous through both of them. So the so we labeled this net VCC, and now there is another connection between R2 and R1, which is going to be a different voltage. And that's this N001 again. You see it says it's 3.235 volts. So what it's telling you is this area here between R1 and R2, this has a voltage of 23529. And that is my voltage that here is called N001. So if I close that window and look here, you'll see that the new wire that I put in from this node to R2, if we look down the bottom left to see what this is called, you see this is VCC again, because everything from source to resistor to R2, these are all going to be the same voltage. Even though there's a junction here, this is the same piece of wire. It's all one continuous piece of copper. And so this is all one voltage, it's all one node or net, and it's called VCC because we named it that. The other one from R2 to R1 is a new net. It's called it N001. Again, I'm looking in the bottom left-hand corner of the window where it tells me, and it tells me what the voltage is at that particular point. And then ground, of course, is from the bottom part of R1, from the bottom part of a resistor, and from the bottom part of our source, and these are all ground. Okay, so you can see how you can quite easily connect up those circuits and easily calculate simple things like the currents through different resistors, etc. If you hover over the resistors, it'll also tell you the currents. And nice thing is it also tells you the power if you look at the bottom line there. Okay, so we are now going to model a little bit more of the a little bit more complicated circuit in the video. But if you want to pause here for a moment, there is another circuit to work at designing, which is in the worksheet. So if you do that before going on to the next bit, that would be great.